Okay, here we go again. Welcome back to Sip and Talk, everyone.
Seriously, this is episode 415-2, recording 2 in one day. We are officially in workaholic mode.
We really are.
Yeah.
But, it feels necessary. Have you noticed how, the whole vibe around AI discussions has shifted lately? It's gotten heavy.
Oh, totally. Yeah. It's not just tech talk anymore, is it? The global conversation, it feels, I don't know, more serious, almost solemn sometimes.
Exactly. It's jumped from, cool new apps to, what some folks are calling an international survival game.
That's a good way to put it. And that's kind of what we want to dig into today, right? This whole tech Cold War that's heating up. We're talking AI, the infrastructure underneath it, national strategies, the works.
Right. It's not just about who has the smartest algorithm anymore. It's about who controls the chips, the data centers, the energy, basically the foundations of the future, a fight for dominance.
So today, we're looking at this through the lens of two, giants. Jensen Huang at NVIDIA, who's building the actual AI factories, and Sam Altman at OpenAI, pushing hard for AGI, artificial general intelligence, and building this massive vertical company to get there.
Two huge visions kind of colliding or maybe feeding each other. We're going to unpack it all step by step.
Yep. We'll start with the immediate shockwaves AI is sending through things like web content, then look at NVIDIA's infrastructure empire, the future of AI and robots and digital workers, Altman's AGI push, and finally the big geopolitical scramble for resources.
Okay, let's dive in. Part 1, the immediate fallout. AI overviews and the content crisis.
Right. So when you search on Google now, and sometimes you get that AI-generated summary at the top?
Yeah, I see those more and more. And I got to admit, sometimes I just read that summary and, I don't click any further. Guilty is charged.
And that right there, that's the core problem. It's what some are calling the convenience trap. Your behavior, my behavior, everyone's behavior, it's actually causing a huge issue for the people who, create the stuff the AI summarizes.
Okay, so how bad is it? Are there actual numbers?
Oh, yeah. The data is pretty stark. Research shows that when one of those AI summaries pops up, the click-through rate, the CTR, on the regular blue links below it, it gets nearly cut in half.
Half. Wow. Okay, if my business relied on website traffic, that sounds like an extinction-level event.
It really could be for some. Think about it. Normally, maybe, say, 15% of people might click a link on the results page. With the AI overview there, that drops to just 8%. People get their answer, or think they do, right there on Google, and they just stop.
And the kicker is, Google's AI is using the content from those websites, content that costs time and money to make, to generate the summary that stops people from visiting the original site.
Exactly. It's a tough spot. And get this, even when the AI summary does cite its sources, with those little links inside the summary box, almost nobody clicks those either.
Seriously?
Yeah, the click-through rate on those cited source links is apparently only about 1%. 1%. So saying, here's where I got it, doesn't really help the original creator financially.
That's profound.
Oh.
It's like the whole highway system of the open web, built on clicks and traffic, is being bypassed by this super fast AI summary booth.
And that leads to what we're calling the content creator survival challenge. News sites, review sites, blogs, investigative journalism outfits, they rely on people clicking through to see ads or click affiliate links.
If the traffic disappears, the revenue disappears. And
the creators might disappear too. We're already seeing lawsuits pop up because of this.
Right, I heard about that. Major media companies are suing.
Yep. Penske Media Corporation, for instance, they own big names like Variety, Rolling Stone, The Hollywood Reporter. So not small players.
Definitely not. What happened to them?
They reported losing over a third, more than 33% of their income from affiliate marketing. Because people read the AI summary, got the gist of a product review maybe, and never clicked through to the article to actually see or click the product link.
A third of their income just gone. Ouch. Especially in media where margins are often thin anyway.
And that's why they're suing Google. The accusation is pretty straightforward. They're saying the AI summaries are illegally basically stealing their copyrighted work without fair payment or permission.
Man, that's a huge tension, isn't it? The AI summaries are super convenient for users. I get that. But how do you balance that convenience with making sure the people creating the information can actually, survive?
It's a massive paradox. Publishers are kind of stuck. If they block Google's AI from reading their site, they vanish from search results. If they let it read their site, they're essentially training the tool that might put them out of business. It's a real catch-22.
Okay, let's shift slightly. When these AI overviews do generate an answer, where are they getting the information from? Is it the same kind of mix you'd see in normal search results?
Mostly, yeah. You see a lot of the usual suspects. Wikipedia, YouTube, Reddit are pretty common sources, probably just because there's so much data there. But interestingly, the analysis showed a subtle bias.
Oh, what kind of bias?
AI summaries tend to cite government websites, the ones ending in .gov, quite a bit more often than regular search results do.
Really? How much more often?
It was something like 6% of the time for AI summaries versus only about 2% for standard search results. So like 3 times more likely to point to a .gov site.
Huh. That suggests the AI algorithm might see government sources as more, official or authoritative.
That's the interpretation, yeah. It seems to lean towards those sources, maybe as a way to seem more reliable or avoid controversial information, which, could be good sometimes, but it might also mean it overlooks really good journalism in favor of a dry government report.
That's a quiet but potentially big shift in how information authority gets decided online. Okay, last thing on this part. When do these summaries actually show up? Is it random?
Not random, no. They don't appear for every search, maybe only about 1/5 of the time overall. But their appearance is strongly linked to how you ask the question.
How so?
They're much more likely to show up if you type in a longer query, like a full sentence or a question starting with how, what, who, or why.
Okay. So if I type in a really specific, maybe like 10-word question.
Then you've got something like a 53% chance of seeing an AI summary. But if you just type in, say, 2 words, that drops way down to maybe 8%.
So the more detailed and curious my question is, the more likely the AI is to just give me the answer up front and stop me from clicking further. That feels paradoxical.
It is. It's the subtle paradox for the learner, as the analysis put it. You show you want deep info, and the AI rewards you with instant gratification. But that gratification comes at the cost of potentially starting the ecosystem that produced the info in the first place.
Wow. Okay, that perfectly sets up the tension. The convenience is high, but the cost to the information source is also potentially devastating. And the infrastructure enabling all this. That's where we need to go next, right? NVIDIA.
Exactly. Let's shift from the user-facing side to the absolute foundation, NVIDIA. You really can't understand the current AI boom without understanding them. And to do that, we kind of have to rewind the clock way back.
How far back are we talking?
Like 1993. That's when NVIDIA was founded.
Okay, 30 years ago. What was the big idea back then?
The core insight, the real foundational idea, was that general-purpose computer chip CPUs weren't going to cut it for the really, really hard computing problems that needed massive amounts of calculations done all at the same time in parallel.
So while everyone else was focused on making CPUs faster, according to Moore's law,
they were betting that eventually Moore's law would slow down and you'd need specialized processors or accelerators for specific kinds of tasks. They focused on domain-specific acceleration from the start.
And their first big success was in graphics, right? GPUs.
Exactly, graphics processing units. Making pretty pictures in video games involves tons of parallel math, so GPUs were perfect for that. But then came the masterstroke, CUDA.
CUDA. I've heard that name. What is it?
It's basically the software layer that let programmers use the GPU not just for graphics, but for, well, almost any kind of heavy-duty parallel computing task. They turned this specialized graphics chip into a general-purpose accelerated computing platform.
Okay, that sounds like a pretty big deal, taking niche hardware and making it broadly useful.
It was huge, and apparently it's super rare in computing history for that kind of transition to happen. It took them, like, the better part of 30 years to really make it work fully, but it meant that when deep learning exploded, which relies heavily on the exact kind of parallel math GPUs excel at NVIDIA, was already there, way ahead of the game.
And that head start, plus how they design things, let them kind of break the limits of Moore's law.
In a way, yeah. Moore's law is about shrinking transistors, and that's getting harder and harder. NVIDIA gets around that slowdown not just with physics, but by designing the entire system together. They don't just sell you a chip, they sell you the whole AI factory.
The AI factory, what does that actually include?
It's the whole stack, designed to work together perfectly. Their own CPUs, their GPUs, super fast networking components, special switches, and crucially, all the software needed to glue it together and make it run efficiently.
So it's like buying a prefabricated, optimized computing plant, not just individual machines.
Precisely. And because they design all these pieces, hardware and software at the same time, they can achieve these massive performance jumps, like roughly 10 times better performance generation over generation. That blows past what you'd get just from Moore's law on its own.
That leads to this AI factory concept Jensen Huang talks about constantly. Why call it a factory, not just a data center?
Because, as he puts it, these centers generate revenue. They're not just storing data, they're actively producing value, like a factory produces goods. And for the companies buying these systems, there's one key metric that Huang says Wall Street doesn't pay enough attention to.
Which is?
Throughput per unit of energy. Basically, how much useful computing work can you get done for every watt of power you consume?
Okay, why is that the most important number?
Think about the scale. These AI systems consume enormous amounts of power. Often, a company's biggest limitation isn't computing power itself, but the amount of electricity they can get or afford. So if you have, say, a fixed energy budget, like 1 gigawatt of power, an NVIDIA system gives you 3 times the performance per watt compared to a competitor.
Then you can effectively generate 3 times more revenue or train 3 times bigger models using the exact same amount of electricity.
Exactly. Higher energy efficiency directly translates into more money or more capability for the customer. It's not just about speed, it's about economic output per watt. NVIDIA isn't just selling chips, they're selling economic leverage through energy efficiency.
That makes total sense. More computation for your energy buck makes you way more profitable or powerful.
Right, and this wasn't just a recent idea. They were thinking this way even with their very first big AI system.
Oh yeah, you mentioned the first one they built, the DGX-1. There's a story there.
Yeah, the DGX-1 back in 2016, it was basically the world's first AI supercomputer in a box. Cost something like $300,000 back then, and the very first one off the line, Jensen Huang apparently hand-delivered it himself.
The CEO himself, who did he deliver it to?
Elon Musk. At OpenAI, Huang literally drove it over, like the ultimate tech support delivery guy.
Wow. Talk about commitment. DoorDash for AI factories. And I guess OpenAI has pretty much built everything on NVIDIA hardware since then?
Largely, yes. That commitment really comes from Huang's deep belief in what AI, specifically deep neural networks, can do, especially with the invention of the transformer architecture, which he calls the ultimate state machine. He believes these networks are universal function approximator.
Okay, universal function approximator. Break that down for us. Sounds kind of jargony.
It basically means that theoretically, if you have enough data and enough computing power, a deep neural network can learn to approximate any mathematical function, no matter how complex.
Any function, like predicting the weather, translating languages, designing a new drug, controlling a robot, all of it.
That's the belief. If a task can be represented as a function input in, output out, then a powerful enough neural network can learn to do it. And if you truly believe that, then AI can potentially solve almost any computing problem.
And if you believe that, then you'd be willing to bet the farm on building the best possible computers for it, right? Reinventing everything.
Exactly. That conviction is why NVIDIA felt justified in redesigning every single layer of computing, the hardware, the networking, the software, all optimized for this one incredibly powerful type of computation.
Okay, so they built the factories. Now, where's the demand heading? We hear a lot about training versus inference.
Right. That's a huge shift happening right now. Initially, the big demand was for training AI models. That's the super intensive process where the AI learns from massive data sets. It's like sending the AI to school.
And once it's trained, it needs to actually do stuff.
That's inference. That's the AI applying what it learned to new situations, making predictions, generating text or images, answering questions in real time. It's the AI actually working or thinking, and the demand is rapidly shifting from mostly training to overwhelmingly inference.
Why does that matter for the hardware for the chips? Are the needs different?
Very different in some ways. Training often requires very high precision calculations and happens in concentrated bursts. Inference needs to happen potentially millions or billions of times per second across countless users and devices, often in real time, and sometimes lower precision is okay as long as it's fast and efficient.
So if most of the computing work in the future will be inference, you need chips optimized for that kind of workload.
Precisely. You need chips designed for massive, scaled-out, real-time application, which is why NVIDIA's newer chips, like Blackwell, are specifically designed with features to accelerate inference performance dramatically. It's about handling this new reality of constant generation and thinking at a planetary scale.
Okay, so NVIDIA is building these incredibly powerful AI factories designed for this new era of constant AI thinking. What kind of products are expected to come out of these factories? What are the big future markets?
Huang highlights 2 absolutely massive categories that could drive trillions in value. First up is what he calls the digital workforce, or agentic AI.
Agentic AI. So this is where AI stops being just a tool we use, like a calculator or a search engine, and starts becoming more like a digital colleague.
Exactly. Think digital software engineers who can write and debug code, digital nurses managing hospital scheduling and patient data, digital accountants performing audits. The idea is that future companies will have a workforce that's a blend of human employees and these autonomous digital agents working together.
That sounds like a fundamental shift in how businesses operate. A multi-trillion-dollar opportunity, you said. So if I'm running a company, what should I be doing now?
The advice given, especially for chief information officers, CIOs, is to start thinking like the HR department for agentic AI. You need to figure out how to onboard these digital employees, how to train them on your company's specific data and processes, how to manage their performance, ensure they follow security rules. It's a whole new management challenge.
Huh. I can just picture the onboarding email. Welcome, Digital Agent 7. Please complete your virtual compliance training by end of day.
Pretty much. Okay, so that's the digital side. The second huge category is physical AI, or robotics. This might be even bigger.
Because it interacts with the real world.
Right. AI with a body. We're talking self-driving robotaxis, obviously, but also advanced surgical robots, warehouse robots picking and packing orders, maybe even humanoid robots helping out in homes or factories eventually. Anything that moves and manipulates the physical world.
How close are we to that? It feels like robotics has been just around the corner for a long time.
Well, Huang offered this really interesting thought experiment, connecting it to those amazing AI video generators like Sora.
Oh, yeah?
He said, look, if an AI like Sora can generate a completely realistic video showing a robot performing a complex task, like perfectly simulating the physics of how objects move and interact, doesn't that mean the AI understands the physics?
I see where he's going.
Yeah.
If it can simulate it accurately.
Then why can't that same underlying intelligence, that same understanding of physics and action, be used to control a real robot to perform the same task? The core intelligence needed seems very similar. It just needs a physical body instead of a virtual canvas.
That's a fascinating point. The intelligence is almost there, just waiting for the right embodiment.
Right. And to make this massive physical AI market happen, NVIDIA says you need 3 key specialized systems working together, like 3 pillars supporting the whole thing.
Okay, the 3 pillars of robotics, what are they?
Pillar 1 is the AI computer. This is the massive computing power needed to train these complex world models and the behavioral policies for the robots. Basically, the AI's brain power gets developed here.
Makes sense.
Pillar 2.
Pillar 2 is the omniverse.
Omniverse. Sounds very metaversy or sci-fi. What is it really?
Think of it as an incredibly realistic, physics-based virtual world, like a super advanced video game engine, but designed as a simulation lab for AI.
A virtual lab. Why do robots need a virtual lab? So they can learn safely and quickly. An AI learning to control a robot arm or drive a car can try things out trillions of times in the Omniverse simulation. It can crash, it can fail, it can learn the laws of physics, how different materials behave, all without breaking expensive hardware or causing danger in the real world. It's a way to generate massive amounts of training data synthetically.
So the AI can practice brain surgery 1,000,000 times in the Omniverse before it ever touches a real patient, or drive billions of virtual miles.
Exactly. Failure is cheap and fast in the simulation. Huang actually mentioned that he thinks the Omniverse is currently undervalued by the market because it's mainly software, not a flashy chip, but he sees it as absolutely essential for developing and scaling physical AI.
Okay, AI computer Omniverse. What's Pillar 3?
Pillar 3 is the robot brain. This is the actual computer inside the robot, the one that runs in the physical world. It takes in data from cameras, sensors, LiDAR, whatever, and makes the real-time decisions to control the robot's movements. It needs to be super fast and efficient. NVIDIA is building tech for all 3 pillars.
This whole vision, from digital agents to physical robots learning in virtual worlds, it sounds like a fundamental change in how computing even works.
It really is. Huang talks about a shift away from the old way of computing, which was mostly retrieval-based.
Retrieval-based, like searching for information.
Yeah. You ask Google to find a web page that already exists. You open a file that's stored on your hard drive. You're retrieving existing information. The new paradigm, he says, is 100% generative.
Generative computing. meaning it creates the answer or the content on the fly.
Exactly. Think about AI like Perplexity. It doesn't just give you links. It writes a unique summary answer for you right then and there. Or Sora, generating every single pixel of a video from scratch based on your text prompt. Even when we chat with an AI like ChatGPT, the conversation is generative. The AI is creating its responses based on the context, not just pulling pre-written lines from a database.
So the old computing was about storing and finding stuff. The new computing is about generating stuff in real time.
That's the core idea. It shifts the focus from storage capacity to real-time generation capacity. And this generative power is opening up totally new areas way beyond just enterprise software or even robots.
Like what? Where else is this heading?
Well, healthcare is a huge one. AI is starting to understand the structure and function of proteins, cells, leading to foundational models for biology itself that could revolutionize drug discovery and diagnostics.
Okay, what else?
Telecommunications AI is expected to be fundamental to designing and managing super complex 5G and future 6G networks. Then there's quantum computing. NVIDIA is building hybrid systems using their GPUs to accelerate quantum simulations, potentially shaving years off development time.
Even finance.
Oh yeah. Quantitative trading, which used to rely on humans designing complex algorithms based on market data, is apparently shifting rapidly towards AI models that learn directly from the data themselves. That's another huge consumer of this AI factory infrastructure. It's touching almost everything.
Okay, so NVIDIA is laying the infrastructure foundation. The factories. Now let's pivot to OpenAI and Sam Altman, who are laser-focused on the ultimate product, AGI.
Right. If Huang is building the mains, Altman is pursuing the end goal, artificial general intelligence, a system that can, think and learn like a human, or potentially even better.
And Altman seems to see the progress towards AGI as this series of almost unexpected breakthroughs.
Yeah, he described deep learning as this miracle that keeps on giving. They thought finding the scaling laws for language models was the huge discovery, but then came better reasoning, and now these incredibly powerful world models like Sora. The progress keeps surprising even them, it seems.
How does something like Sora, the video generator, fit into the grand plan for AGI? It feels more like a creative tool.
Altman's view is that building these powerful world models, AIs that genuinely understand how the physical world works, how objects interact, the basics of physics, which Sora clearly has to do to make realistic videos, it's actually a crucial stepping stone towards AGI. You need that grounding in reality.
Okay, that makes sense. You need to understand the world to be generally intelligent within it. He also had an interesting take on how society reacts to these breakthroughs, right? Something about the Turing test.
Yeah, he made this comment that the whole classic idea of the Turing test, this single moment where an AI fools a human and it causes this global shock, that moment basically went whooshing by with things like ChatGPT, and society mostly just shrugged and adapted.
Yeah, there was maybe 2 weeks of panic, and then everyone just started using it for work or homework.
Exactly. His point is that AGI likely won't arrive as this single dramatic Big Bang event. It'll probably be more of a continuous, accelerating rollout of increasingly capable systems, and society will likely adapt along the way, just like it always has.
We adapt remarkably fast, which probably informs his views on safety and regulation, I imagine. But first, let's talk about OpenAI's structure. It's kind of unusual, isn't it? Part research lab, part giant tech company.
It is. It's a research lab, a massive infrastructure operation managing huge computing resources, and a consumer tech business selling API access and products like ChatGPT+. This leads them to a strategy of intense vertical integration.
Vertical integration, meaning they try to do everything in-house.
Pretty much. Altman actually admitted he was initially against it. He thought they should just focus purely on research. But he said he realized he was wrong. To actually achieve the mission of building AGI safely and effectively, they had to integrate vertically.
Why? What's the connection?
Because the cutting-edge research needs massive, specialized computing infrastructure that might not exist elsewhere. And building that infrastructure requires the resources and focus of a major product company. And having great products generates the revenue and data to fuel more research and build more infrastructure. It's a cycle. Research enables products. Products fund infrastructure. Infrastructure enables research.
So they couldn't rely on others. They had to build the whole stack themselves to control their own destiny towards AGI.
Kind of like Apple with the iPhone, right? Altman himself apparently drew that comparison. He called the highly vertically integrated iPhone the most incredible product the tech industry has ever produced. That level of control is what they feel they need to push the AGI frontier.
But pushing that frontier, training these ever larger models, It takes an astronomical amount of resources, doesn't it? Especially energy.
That's the looming crisis. Altman is very clear that the kind of AI growth they anticipate, especially if we get towards AGI, will put absolutely massive, potentially unsustainable demands on the world's energy grids.
So what's the solution? Just build more power plants?
Not just any power plants. He stresses the need for radically cheaper, more abundant, and crucially reliable 247 power. Solar and wind with storage are great, he says, but they might not be enough for the kind of high-density, constant tower draw these massive AI training runs require.
So what does that leave? Nuclear.
That seems to be the implication. He talks about needing breakthroughs in energy, specifically mentioning things like advanced nuclear reactors, small modular reactors, SMRs, and maybe even fusion down the line.
SMRs, those are the smaller factory-built reactors, right? Potentially quicker and cheaper to build.
That's the idea, yeah. Smaller, potentially safer, easier to deploy. The point is, without a major breakthrough in cheap, clean, reliable energy, the sheer power demands of advanced AI could become a bottleneck.
And the policy implication is pretty clear. If nuclear power suddenly became drastically cheaper and safer, the political roadblocks might vanish pretty quickly because the need for that energy for AI dominance would be so immense.
Absolutely. Cheap, abundant energy becomes a strategic necessity for leading in AI. Okay, shifting gears slightly to safety. Altman talks a lot about AI safety and risk, but his approach seems focused.
Focus how? He acknowledges the risks, right?
Oh, definitely. He says strange or scary moments are basically inevitable with powerful new tech. It happened with fire, it happened with electricity, it'll happen with AI. His philosophy seems to be centered on stewardship.
Stewardship.
Meaning focusing the really heavy-duty safety testing, the audits, the government regulation, only on the models at the absolute cutting edge, the ones that are starting to show signs of being truly, extremely superhuman, as he put it.
Wait, only regulate the super intelligent ones. Isn't that a bit late? Like locking the stable door after the super horse is bolted?
That's the criticism, yeah. But his counterargument is about pace and competition. He worries that applying heavy regulations to all AI models, including the less capable ones we have today, what he called a European-style complete clampdown, would be dangerous.
Why dangerous? Wouldn't slowing things down be safer?
Because, he argues, if the US and Europe slow down too much due to regulation, other places, particularly China, might race ahead with fewer restrictions. And in his view, falling behind in the AI race is a massive national security risk in itself.
Ah, the geopolitical angle again. So the strategy is stay ahead, develop faster, but also more safely than anyone else, and only apply the really strict controls when you reach genuinely unprecedented levels of capability. It's a balancing act.
It's a very fine line to walk, balancing rapid progress with existential risk mitigation, especially in a competitive global environment.
Which brings us perfectly to part 5, the direct geopolitical struggle over the resources needed for this AI future.
Exactly. All this talk about infrastructure, AGI, robots moving in the physical world, it all boils down to controlling key physical resources. And right now, that conflict is playing out primarily between the US and China using 2 main points of leverage.
Okay, what are the 2 key resources they're fighting over?
Semiconductors, the advanced chips needed to train and run the AI models, and rare earth magnets.
Why rare earth magnets specifically?
Because as AI moves into the physical world, self-driving cars, drones, robots, you need high-performance electric motors to make them move precisely and efficiently. And the most powerful lightweight electric motors rely on strong magnets made from rare earth elements.
Got it. So chips for the AI brains, magnets for the AI bodies. And the leverage is?
The U.S. currently has significant leverage over the supply of the most advanced AI chips through companies like NVIDIA and AMD. They've used export controls to significantly restrict China's access to these cutting-edge chips, aiming to slow down their AI development.
Okay, that's the U.S. leverage. What's China's counter?
China's potential leverage is its overwhelming dominance in the processing of rare earth elements and the manufacturing of the magnets themselves. They control something like 90% or more of the global supply chain for this, so their potential retaliation for chip controls could be restricting the export of these crucial magnets.
Wow, 90%. That's a huge dependency for the rest of the world, including the U.S.
Yeah.
Which explains this push for sovereign AI, right?
Precisely. Sovereign AI is the idea that nations realize they cannot afford to be completely dependent on another country, especially a rival, for the core technologies and resources driving their future economy and national security. You can't just outsource all your data, send it off to be processed into intelligence, and then import the answers back without taking on massive risks.
So countries are thinking, we need to build our own AI capabilities, our own infrastructure, even if it's more expensive.
Exactly. We're seeing countries like the UK, France, Germany, Japan, and others actively pursuing this. It's often a hybrid strategy. They still need to import technology and buy services from, say, US cloud giants, but they're also investing heavily in building their own domestic AI infrastructure and talent pools to have some level of sovereign control.
Okay, so back to the US, trying to fix that rare earth magnet vulnerability. What are they actually doing?
The U.S. government is getting directly involved using national security justifications to try and rebuild a domestic supply chain. They're actively supporting American companies like USA Rare Earths and MP Materials.
And these companies argue it's not enough just to dig the minerals out of the ground in the U.S., right?
No, that's the key point MP Materials makes. True security requires vertical integration. You need the capability not just to mine the ore, but to do the complex chemical processing to separate the rare earth elements, and then to actually manufacture the finished high-performance magnets right here. They call this integrated supply chain the essential feedstock for the future of war and physical AI. Relying on China for the final critical magnet component is the vulnerability they need to eliminate.
But rebuilding that entire industrial chain must be incredibly expensive and difficult, especially when China has been doing it cheaply for decades. How is the government helping these U.S. companies overcome that?
They're using a couple of powerful tools. One is regulatory relief. They're apparently streamlining or bypassing some environmental regulations to allow these companies to develop mines and build processing plants much faster than would normally be allowed.
Okay, speeding things up helps. But what about the cost? How can U.S. companies compete if China floods the market with cheap magnets?
That's where the second tool comes in. Market stability, basically guaranteed by the government. The government is stepping in to act as a long-term guaranteed customer.
How does that work?
They're offering long-term purchase contracts, potentially spanning decades, and setting price floors. This means the government guarantees it will buy a certain amount of domestically produced rare earths or magnets at a minimum price, no matter how low the global price might drop.
So that takes away the biggest risk for investors. If you know you have a guaranteed buy or at a guaranteed minimum price for the next 20 years, you can actually raise the billions needed to build the mines and factories.
Exactly. It transforms a volatile, risky commodity business into something much more stable and predictable, like a utility. It allows these companies to make the huge upfront investments needed for vertical integration without the constant fear of being immediately bankrupted by state-subsidized foreign competition.
It's fascinating. It's like the U.S. realized that decades of prioritizing short-term cost savings by importing cheap rare earths created this massive long-term national security hole. And now they're using government power to basically de-risk the market and force a domestic industry back into existence.
That's precisely the dynamic. The stakes are incredibly high. Control over these materials, the silicon for the brains, the magnets for the bodies, is seen as fundamental to winning the AI arms race and shaping the future of both economic and military power.
Wow. Okay. That was a lot. We really covered the spectrum today.
I really did. From, the immediate pain point for website owners seeing their traffic slashed by AI summaries.
Yeah, that 15% down to 8% click rate and the 1% on citations. Brutal.
All the way up to Jensen Huang's vision of NVIDIA building these globe-spanning AI factories, driven by that key metric of throughput per watt.
And breaking Moore's law with that 10x generational leap through vertical integration.
Then exploring those huge future markets, the trillions in digital agentic AI, the potentially even larger market for physical AI learning in the omniverse.
Right, the three pillars: AI computer, omniverse, robot brain. And that shift to 100% generative computing.
Contrasted with Sam Altman's laser focus on AGI at OpenAI, their necessary vertical integration, and the massive energy challenges that come with it, pushing towards advanced nuclear.
And finally landing on the stark geopolitical reality. The U.S. using chip controls, China holding the rare earth magnet leverage, and the global push for sovereign AI to reduce dependency.
Phew. So, as always here on Sip and Talk, our aim was just to lay out the facts, the strategies, the data points from all this complexity. We're presenting it objectively, trying to give you the context you need.
Yeah, we're not taking sides here, definitely not endorsing any particular political view or criticizing any group or nation. The goal is just to share the information so you, our listeners, can think critically and independently about these huge world-shaping issues.
Absolutely. Independent thought is key.
So, to leave you with something to chew on, building on that idea of generative computing we discussed, here's a thought. If AI really is moving computing towards being 100% generative, where answers, images, videos are synthesized on the fly, not retrieved what value is left in static, retrieved information, how do we even define truth or fact in a world where everything is potentially a real-time dynamic synthesis?
Ooh, that's a good one. Definitely something to ponder. That'll keep us thinking until the next time.
It will indeed. Before you go, please do subscribe to Sip and Talk if you haven't already. And hey, also check out our good friend Mickey's YouTube channel. It's called Mickytolife. He's got fun memes, reviews, and his latest vlogs from Europe are up now. Always entertaining.
Definitely check Mickey out. All right, we'll catch you on the next one.
Thanks for tuning in. Goodbye.